Welcome to GeoMind. This is the first video of our channel, and this channel is aimed at students who are preparing for various examinations such as UPSC, and this channel will especially focus on subjects like geography, geology, and earth sciences. So, if you are a student of geology, geography, or if you are a curious person who wants to know how Earth works, wants to know more about the Earth as a planet, please subscribe to the channel and like the video. If you like it, please let me know in the comments whether I should upload more videos or not. Lastly, this is the first video, so if there are any mistakes, please let me know and I will rectify it. Okay, so let's talk about the first topic, that is evolution of Earth. So sorry about that. My first language is not English, so I might not be that fluent. If you want to, if you want me to speak in Hindi, I can speak in Hindi too. Okay. So let's talk about evolution of Earth. So first, talking about evolution of Earth, we need to know that is Earth unique and why is it unique? Is Earth unique? That's a very simple question, and it can be answered by a simple fact that Earth is unique because it can support life. It has water, okay, and life is almost everywhere in Earth. It is ubiquitous, found in boiling mud, hot springs, deep abyss of the ocean, and though a human can't live in deep abyss of ocean, but there are several creatures who can live there. But there are some exceptional places like this Danikil. Danikil is what? Danikil is in Ethiopia. Ethiopia is in Africa. So this is the Horn of Africa, something like this. Okay, this is the Arabian Peninsula, and Ethiopia is somewhere here. Okay, so Danikil Depression is a place in Ethiopia where you can't find any life. Even the resilient of bacteria such as Archaea bacteria is not found here. Why is that? Because Danikil Depression is hyper saline and hyper acidic. That's why, and it lies on the hot spot here. I think hot spot's name is Afar. Afar hotspot. So if you want to note it, you can note it down. Afar hotspot, the Danikil Depression, and it's in Africa. And you can't find any life. You can find any life here. So there's that. But most of the place is hospitable for life, and for humans, not most of the place is hospitable because you can't live in the ocean. You can't live in the mountains, okay, such as Himalayas. You can't even live last 10 minutes or longer. So so this Danikil, I might know the spelling correctly, so correct me the spelling. Now let's talk about so we have addressed this question, that is Earth unique. Earth is unique, definitely. It might not be too hospitable for our for humans, but out of 8 planets is definitely the most accommodating. Now let's talk about the origin of planet Earth. Now before talking about the origin of planet Earth, we need to know the origin of the universe, and we know that the universe began 13.7 billion years ago with a big bang, and with a large explosion it sent all matter of the universe flying outward at an incredible speeds, and this matter mostly contained hydrogen and helium. Okay, this matter mostly contained hydrogen and helium, the two most abundant elements in the universe right now. Now with the time, this debris from this explosion With time, this debris from the explosion began to cool and condense into first stars and galaxies, and then one of these galaxies in Milky Way, our solar system, was formed. And with solar system, planets were formed. Okay. Now there are many theories given by different scientists for the origin of planet Earth. I think there are around 6 to 7 theories. The most widely accepted theory is the nebular theory. Okay, it was given by Kant in 1755 and it was modified by Laplace in 1796. Now there are other theories such as planetesimal theory, tidal theory, magnetic theory. I think tidal theory was given by Littleton. Planetesimal was given by Moulton and Chamberlain in 1905. So if you want me to talk about all those theories, I can make separate videos on it. But for the time being, even in the modern days, nebular theory is the most widely accepted theory, okay, of the origin of planet Earth. So what nebular theory states is that there was a huge nebular cloud. Okay, so what is nebula? Nebula is nothing but just a cloud of interstellar dust and gas. Okay, and this cloud mostly contains hydrogen and helium and other ionized gases. So what happened was that, by the way, nebulas are huge. Uh, if you look up to the images of Hubble, you can see different nebulas such as Cat's Eye Nebula, Orion Nebula. Okay, this I think there is one famous photo called Pillars of Creation. It's a very uh, Pillars of Creation is, I think, in Eagle Nebula. So if you want to find out, you can search it in YouTube or net, and you can just Google that image, Eagle Nebula, Pillars of Creation. Very interesting photo, and you can see these nebula in actual sense. So now coming back to the theory, the theory states that the birth of solar system began as a dust and gases started to gravitationally collapse. So nebula started to collapse and it started to rotate. Now with angular conservation of angular momentum, as its size decreased, its rotation speed increased, and in its center, the proto-sun was formed due to fusion of hydrogen and helium. And the rings were formed. Now with time, these rings started to accumulate into smaller debris with the size almost that of asteroid-sized bodies. And within few million years, these bodies accreted into planets. So that's how our Earth was formed. Now we know that the Earth is the right planet to harbor life, because if Earth was considerably larger, its force of gravity would be proportionally greater. Okay, like that of giant planets such as Jupiter. Okay, and Earth would have retained a thick hostile atmosphere consisting of ammonia and methane. As you know, the giant planets have very thick atmosphere. If you talk about Jupiter, Saturn, Neptune, their atmosphere is very thick. And second point is, if Earth was much smaller, oxygen would have escaped into space, or even every uh, gas present in the atmosphere, even the atmosphere wouldn't be there, because if Earth was smaller, the gravity field would be, if Earth was smaller, the atmosphere around it would escape, because gravity wouldn't be much higher to retain that atmosphere. And if it was large enough, the atmosphere would be thick. Okay, sorry about my drawing, because I'm drawing with the mouse, so please bear with it. I just want to show that if Earth was smaller, too small, too large. Too large. So what it's trying to say is that Earth is the right planet to harbor life, because if it was much smaller, the atmosphere would escape because of low gravity, and if it was too large, there would be thick atmosphere and we wouldn't survive. Okay. Now, secondly, if Earth didn't have rigid lithosphere, okay, so there wouldn't be plate tectonics, and if there wouldn't be plate tectonics, mountains wouldn't have formed, and if there was no high land, Earth would have just covered by an ocean a few kilometer deep, and there wouldn't be any land to live upon. Okay. Fourth is if Earth didn't have molten metallic core, there wouldn't be magnetic field, and if there wouldn't be magnetic field, cosmic rays would just be lethal, okay, for the organism living in this planet. So all these points make Earth a suitable planet for harboring life. Earth is also in the just right location, because it's the primary factor which determine whether planet is suitable for higher form of life or not. Okay, because if Earth was 10% closer to the sun, uh, it would be just like Venus, and there would be a greenhouse gas, runaway greenhouse gas effect, and the temperature would be too hot. And if Earth was 10% farther away from where it is now, the ocean would just freeze, and we would just, we would just freeze. That's it. Also, our star is also the perfect size, because if it was larger, its fuel would run out. Okay, most likely its fuel would run out, and it wouldn't have any it wouldn't have much time left for us to evolve. So sun's age is 10 billion years, and it has already been 4.5 billion years for us to evolve. So if it was a red giant, like stars like Betelgeuse or Antares, these all are very giant stars, and they have very small lifespan, okay, compared to the mid-sequence star such as Sun. So in summary, Earth's proximity to a modest-sized star allowed enough time for the evolution of human, and that's why the sun is also important. Apart from that, it gives life and all those things. Also, the right time. The last but certainly not least, the fortress factor is timing. The first organism to inhabit Earth was extremely primitive and came into existence roughly 3.8 billion years ago. So you want to note that the first organisms were eukaryotes, I think eukaryotes, yes, green algae, green blue algae, and they were 3.8 billion years ago. First form of life was present. And from this point on, the Earth's innumerable changes occurred, and life forms came and went along with changes in the physical environment. So the first form of life was 3.8 billion years ago, but the bacteria which started to photosynthesize and release oxygen into the atmosphere came about 2.2 billion years ago. Okay, so earlier there was no free oxygen. So that's it for this video. I hope you like it. Please comment down below whether I should upload the part 2 or not. In next video, I will be talking about evolution of Earth's atmosphere and the geologic time. Okay, thank you.